Well, welcome everybody to another edition of Lewis at Large. Yours truly, Warner Lewis from the flight deck. And of course, that means some very smart talk radio is in your future, and this segment, no exception. We have done probably 650 to 700 shows in the history of this broadcast. We have never done one exclusively on earthquakes and volcanoes, and we will do that at this time. It is long overdue. Very happy to have as our guest Dr. Peter Ward. He worked on earthquake and volcano risk for 27 years with the U.S. Geological Survey. He played a key role in developing the U.S. National Earthquake Hazard Reduction Program. His specialty is communicating earthquake risk to the general public, how to minimize earthquake loss, and much, much more. We're not here to shock you or to alarm you, but to educate you. And with that as an introduction, Dr. Ward, how are you, my friend?
I'm very fine.
Good. Well, go ahead. Let's do this. Let's give our Lewis at Large listeners a little bit more setup for you. Tell us a little bit about education for you, and why did earthquakes and volcanoes intrigue you at an early age?
I graduated from Dartmouth College and went on to a PhD from Columbia University. Back as a freshman, I had signed up for geography, and the registrar said, "Sorry, it's full. What are you going to take?" And I thought quickly, geology. And I ended up, the professor teaching geology was a specialist in volcanoes, and I was hooked for the rest of my life.
And again, earthquakes, and let's focus on earthquakes here just at the beginning. Long a part of the history of this earth. Can you give us just a general definition of what an earthquake is, maybe versus a tremor? They are obviously in the same family. What's the difference, and why do they occur from just sort of a high-level view?
Well, an earthquake is when there's slip on some crack in the earth. And if that crack is a big, long crack, like 1,000 miles long or whatever, you get a very, very big earthquake. If it's a small crack, you get a small earthquake. We have lots and lots of small earthquakes, but the really big ones are fairly rare.
Just in general, statistically, is the planet experiencing more earthquakes, let's say, over the last decade than before, or are they hard to predict and they just come and go as they wish?
There's no reason to suspect any significant change in the rate of earthquakes. We have gigantic earthquakes about every 10 or 20 years, and other ones in between. There is some question now of whether man is generating earthquakes by injecting fluids into the ground. In this case, these are relatively small earthquakes, maybe large enough to be felt, but usually not damage-causing. But otherwise, there's no real evidence that there's a major change. But certainly public interest changes depending, after a giant earthquake. All my years at the Geological Survey, the phones start ringing, and people get very concerned once there's been a big earthquake somewhere like the recent one in Tibet.
Yeah, I wanted to follow up on that. Talk to the ones of the big earthquakes they've had over in that area recently, and are those unique in any way, shape, or form, or, so to speak, another just, unfortunately, garden variety earthquake?
Well, the interesting thing is, the earthquakes are very common where you get big mountains, and that's why you have them there. We have earthquakes here in Jackson Hole, where I live, because the Tetons is a big, steep fault, essentially. And the same with the Himalayas. What's really interesting about the Tibet earthquake is the detailed studies following it show that maybe it's just the predecessor for a really severe earthquake, that there could be a much bigger earthquake. And this gets down to the issue of what fault broke and how long the fault could go.
What about, and again, in this area, New Madrid, Missouri, had some major quakes back in the early 1800s, not far from here, some 400 to 500 miles from here. And what about this area in general? There's been a lot of talk about the potential for the earthquakes, believe it or not, right in the heart of the country.
Well, if you look at an earthquake risk map of the United States, you can download something like that from the usgs.gov website. There's a big bullseye right over New Madrid, southeast Missouri. There were very large quakes there, magnitude 7 to 8, 4 of them back in 1811, 1812. They shook the ground so hard that they actually rang church bells in Boston, Massachusetts. So we're talking gigantic earthquakes, and it's not exactly clear why they're there. They're not exactly the same kind of thing as we see in California or in the Himalayas.
And again, as you say, major quakes are going to happen, whether we want them to happen or not. What is and again, part of your job, I know, was helping to sort of predict those, make it become more of a science, and worrying and concerned yourself with risk. What are some of the things maybe the general public doesn't know or maybe needs to know about this phenomena?
Well, let's take those one at a time. I mean, one is the issue of predicting earthquakes. There was a time in the 1970s when we were observing many measurable things that seemed to be precursors to big earthquakes. And that's when we developed the National Earthquake Hazard Reduction Program, and we tried to monitor these anomalies better. Unfortunately, the earthquakes didn't come to the party where we had put all our instruments, and over the period of time, we really weren't able to get the data we had hoped to be able to predict earthquakes. Now, with GPS and new kinds of instruments, it may be possible to begin to talk about that again, but our emphasis has been much more on hazard reduction, and especially in the United States, because in the United States, big earthquakes were likely to survive relatively well because most of us live in wood frame homes that flex during an earthquake and don't break. Whereas what we see in Nepal and in China and much of Central America and other places, where the buildings are made of mud and bricks and stone, they just don't hold together as well, and they collapse on people and kill lots of people. So in the United States, we're much more concerned about being savvy about when earthquakes are possible and taking various actions to try to reduce the damage that would occur at that time and to make our lives safer at that time.
If you just joined us, yours truly, Warner Lewis, from the flight deck of Lewis at Large Radio. And, of course, in this segment, we are talking natural disasters. We're talking earthquakes, and we'll also talk a little bit about volcanoes with Dr. Peter Ward, who for 27 years was with the U.S. Geological Survey, playing a key role in developing a lot of our national hazard reduction programs. He also specializes in communicating earthquake risk to the general public, as we are doing right this minute. What about Dr. Ward? I suppose that a discussion of earthquakes has to involve in some way, shape, or form the concept of climate change, and I would like to hear an ozone deletion, so to speak. If you would share your take on that, and how much first of all, A, is that happening, and B, in your opinion, is it affecting our risk for earthquakes?
Well, I wouldn't mix those two things together. The main thing I am working on at the moment is ozone depletion as an explanation for climate change. And there are two ways to deplete ozone. One is with chlorofluorocarbons, CFCs, the kind of things we used in spray cans in the late 1960s, and we fixed that problem. And the other way of depleting ozone is from volcanoes, and that's the whole story in itself. In terms of their relationship with earthquakes, I don't know of any relationship between climate and earthquakes.
Well, is there anything outside of going back to the earthquake risk, if not related at all to climate change, are there any other factors outside of what naturally happens under our ground? Is there anything external that could possibly affect earthquakes?
Well, earthquakes result from a buildup of stress in the ground. And if you just think of holding a stick in your hand and bending it very slowly, that's building up the stress in the stick. And then you hear little cracks. Well, those are little earthquakes as pieces of the stick break. And if you bend it far enough, you get a big earthquake when the stick breaks in half. So it's a buildup of stress. And it's possible, it's conceivable that by injecting fluid into the ground, you can help lubricate the fault, essentially, by reducing the stress, by reducing the friction across the fault and allow the fault to slip. We first learned about this in the early 1960s when, at the Rocky Mountain Arsenal outside of Denver, they began injecting large amounts of fluid waste into the ground. and we began to have some felt earthquakes. And this was studied at great length, and it's been discovered since then that injection to get secondary recovery of oil in oil fields, we saw a big effect on earthquakes in the Rangeley oil fields in northwestern Colorado in the 1970s. So there is evidence that man can have some small effect, but what we're talking about is man perhaps triggering magnitude 3 and 4 earthquakes that you can feel. It's pretty rare that there's been any evidence of man triggering something bigger than that. Now, one of the places that's going on near where most of the listeners live is in Jones, Oklahoma, just northeast of Oklahoma City, where they're injecting massive amounts of wastewater from oil and gas extraction operations into the ground. There are over 9,000 injection wells in Oklahoma, but there are 4 that have been pumping huge amounts of fluid every day. And these have generated a number of small earthquakes. And there's some concern that there is a fault in that region, the Nemaha Fault, running through Oklahoma City, that if that were caused to slip, it could cause a magnitude 7 earthquake, which would be very, very damaging. And so there's a lot of concern looking at that, a lot of people recording earthquakes there and studying it. There was an excellent article in Science in the middle of last year describing the whole situation there.
Dr. Ward, does an earthquake, is it possible one earthquake begats others, meaning if the ground is rumbling and shifting at such a level, does that vibrations from that and that phenomena cause other ground that might not necessarily trigger on its own? Can it spread, so to speak?
Well, the really gigantic earthquakes are several faults end to end. And so, as I said earlier, the biggest magnitude earthquakes are those that break over, say, 1,000 miles. And it's possible that something like that could start and stop sooner than it's likely to stop. And that's exactly what's going on in Nepal right now, that this recent earthquake was big, but it could, particular geography of it and the way they look at it at the moment, it could have been bigger. And in fact, it could even lead to the triggering of a bigger earthquake. We also have spent a lot of time looking for foreshocks, smaller earthquakes that presage a bigger earthquake coming. The only clear way to identify a foreshock is after the big earthquake. You can look back and say, oh, that must have been a foreshock. Foreshocks don't tell you when they happen that they're a foreshock. So there is a question of relationship there. Many earthquakes are preceded by foreshocks, many are not. There's also a possibility there's been some interesting data in the last decade or so suggesting that really gigantic earthquakes like the one in Japan in 2011 has some effect even on earthquakes in California. We don't understand something like this. It doesn't make a lot of sense, but we're beginning to see data that cause us to wonder. And we know the surface of the Earth is made up of a number of large plates, about a dozen plates that are moving relative to each other. So it certainly is possible that a major motion on one edge of the plate, such as the Japan earthquake, could cause the plate to shift enough that it might change stresses other places.
When it comes to sort of predicting or having an awareness of areas that might potentially be at risk for earthquakes, how far have we come in the 60s, 70s, 80s, 90s, and the current decades in front of this one? How far has the technology come, and are we pretty good at it, so to speak, or are we still maybe in its infancy in predicting?
Well, we are very good at predicting the regions where earthquakes are likely to occur. We know, for example, in Jackson Hole, Wyoming, that a magnitude 7 earthquake is likely to occur. We don't know if it's going to be today, a year from now, or 100 years from now, but it will occur. And we can say that clearly about most places. For example, the Cascadia subduction zone that goes from Cape Mendocino in Northern California all the way up to Vancouver Island slipped in a major earthquake in 1700. And that earthquake is likely to repeat itself, and it will be a gigantic earthquake. But it may not repeat itself for another several hundred years. So we have maps all over the world of where earthquakes have occurred and basically what the statistical chance is of earthquakes occurring in the future. But being able to predict a specific earthquake is not something we can do at the moment.
Do you, let's take this, and again, this is not your area of specialty, but overall, because we have a much better sense of where things may happen, is there really much that local civil defense and other authorities can do to prepare? What, other than educating the public, and beyond that, what really can they do? What would be your suggestions?
Well, there's a great deal being done. I mean, the emergency managers across this country are a very capable lot of people, and each emergency manager knows what the hazards are in the region they're responsible for, and they very often have had plans, developed plans, and even practice plans for reacting to those hazards, whatever are most likely to occur. Now, the insurance companies, of course, are very much involved with damage, and they know where the major earthquakes are likely to occur. And in places like California, every realtor has a map that is available from the insurance reinsuring companies showing where the faults are, that advise people not to buy directly on a fault. And if you live near a fault, there are now building regulations, especially in California, that say you have to strengthen your home in certain ways if you're this distance or less from a fault. So we've already taken a lot of the knowledge that came out of earthquakes like the Alaskan earthquake in 1964 and the earthquakes in Southern California in 1970 and turned that into regulations for building codes, turned that into regulations for zoning, turned that into planning in terms of what the prospective damage could be in a given area. So I think in terms of hazard reduction, we've actually done a very good job, and the emergency managers listen very carefully to that.
Again, we're talking to Dr. Peter Ward, who for 27 years was with the U.S. Geological Survey, played a key role in developing the U.S. National Earthquake Hazard Reduction Program, where obviously we're talking about earthquakes, going to touch a little bit here also on volcanoes. But again, when it comes to earthquakes, how much cooperation is there between, say, the U.S. Geological Survey and other like organizations around the world? Is this the kind of thing that everybody is really focused on, or are we kind of leading the way here?
Everybody is focused on it. The U.S. Geological Survey in Denver, Colorado, locates earthquakes worldwide and puts out a great deal of information. If you simply go to usgs.gov and search on earthquakes, you'll get information of what earthquakes are occurring right now, have occurred recently. It's a place you can also report if you felt an earthquake. And we get hundreds to thousands of those reports after any major or small earthquake in the western U.S. There are worldwide maps. There are maps of specific locations. There are many scientists that are working with people in Central and South America, all across Nepal regions, China region, in terms of collecting information on what earthquakes have happened in the past, what earthquakes are likely to happen in the future. Organizations like the World Bank are quite savvy on this issue when they put out money for development. There's actually a very robust community of scientists, community planners, government all across the world that are concerned about earthquakes and are working together to try to find ways to develop safer communities and to educate people about how to survive earthquakes when they do occur.
Let's before we wind down here, let's also touch. We definitely want to touch on volcanoes. And again, you were talking about the ozone depletion theory and things behind that and climate change. Talk about your work within that area, if you would.
Well, I would say, first of all, that in the 1970s, early 70s, I was developing a prototype volcano surveillance system worldwide. And to test that, we put instruments in Alaska, Iceland, all down through western North America, down through Central America, that recorded earthquakes and looked for increases of activity at different volcanoes. And that data was sent by satellite back to my office in Menlo Park, California. We demonstrated then, and it's been shown now, that volcanoes are much more predictable. For example, when Mount St. Helens blew in 1980, in the months preceding, there were major magnitude 5 earthquakes felt in that region. So we are able to notice where volcanoes are becoming active again. And in the case of Pinatubo in 1991, not only did we know it was getting more active, but we put crews on the ground, and they worked with the local Filipino government, and they actually were able to predict the major eruption and to get people out of the way. So we're doing fairly well predicting that volcanoes are likely to blow, and in most cases, when specifically they're likely to blow. Now, when you go back to ozone, one of the interesting things is that volcanoes deplete the ozone layer. And when the gases, chlorine and bromine that come out of volcanoes, kill ozone, deplete ozone. And when you deplete the ozone layer, hotter radiation than usual reaches Earth. This is ultraviolet B radiation that can burn your skin. It causes skin cancer. And normally we're protected by the ozone layer, by that being absorbed up there in the stratosphere. But when you deplete the ozone, more of that comes to Earth. And what I've discovered is that that's one of the causes for global warming. If we can actually measure the depletion of ozone, we can measure the increase in ultraviolet B radiation arriving at Earth, and we know that that radiation is really hot. It's about 48 times hotter than the radiation absorbed by greenhouse gases. We've also noticed in Iceland that before the eruption of Eyjafjallajökull in 2010, the volcano that caused so much disturbance to air traffic, that there was a huge emission of ozone from the volcano about a month before the volcano blew, exactly at the time that we could see magma deep in the earth moving up towards the surface. We don't know what this means. It's an area of research. It could be very useful predicting volcanoes in the future, but it doesn't make a lot of sense. But that's the kind of thing that keeps scientists busy.
Indeed, it does. Boy, I would like to continue talking and exploring this. We're starting to run out of time here. Let's do this. Dr. Ward, if you would share with our listeners how people can find out more information on earthquakes and also, of course, volcanoes and some of the work that you're doing.
If you go to tetontectonics.org, TETONTECTONICS.org, and you click on earthquakes, you'll get a great deal of information about living with earthquakes. If you click on climate, it'll refer you to a website that talks about climate in great detail. If you click on warning, it'll tell you about a lot of work that I did on warning people of hazards, specifically at the time, like a tornado is right outside your town and get ready. And then you can also click on volcanoes and learn a lot there. Another excellent source of information is usgs.gov, and I encourage anybody just to Google a question they have about earthquakes or volcanoes, and you'll be amazed at some of the information you'll get.
Well, I appreciate it very much. Again, in some 700 shows, we've never specifically talked about earthquakes. We appreciate your perspective and knowledge on it, and best of luck to you in the future. We'd like to have you back on again sometime.
Well, Warner, it's been fun, and I'd be happy to talk to you in the future about climate.
Sounds great. Listen, thank you so much, and we'll be back with more right after this on Lewis at Large.